looked at a structure and thought, how did humans even build that? From record-breaking skyscrapers to machines buried deep underground, some projects are so extreme they almost look impossible. In this video, we'll explore 7 of the most extreme engineering projects in the world, and what makes each one a masterpiece of design, money, and pure human stubbornness. Watch till the end and tell which one deserves its own full documentary. Number 7, the Burj Khalifa in Dubai. At over 800 meters tall and more than 160 floors, this isn't just a tall building, it's a vertical city pushing deep into the sky. The biggest enemy at that height is not the weight of the building, but the wind. If the air currents swirl too strongly around a tower, they can create vibrations that make people feel sick, damage the structure, or in extreme cases cause failure. To solve this, engineers used a buttressed core design, a Y-shaped floor plan where 3 wings support a central core. This shape helps spread the forces and breaks up wind patterns, so the tower flexes safely instead of fighting every gust. Even the concrete is special. Ordinary concrete would crack under Dubai's heat and the loads at high levels. So the team used high-strength mixes and poured a huge amount of concrete at night, when temperatures were lower, then pumped it hundreds of meters up, another record on its own. The Burj isn't just about height, it's proof that with the right shape, materials, and planning, engineers can bend both gravity and wind to their will. Number 6, the Channel Tunnel, linking the United Kingdom and France. On the surface, it's just a train ride. But beneath the English Channel lies more than 50 kilometers of tunnel with about 37 kilometers running under the seabed, one of the longest undersea tunnels on Earth. Engineers had to dig through soft chalk under high water pressure, knowing that the sea was literally above their heads. They used massive tunnel boring machines working from both the British and French sides. Every meter, they checked alignment, pressure, and ground behavior. When the two ends finally met in 1990, the breakthrough was accurate to just a few centimeters. Safety was a second huge challenge. Instead of one tunnel, there are 3, 2 rail tunnels and 1 central service tunnel. In an emergency, passengers can be evacuated into the service tunnel, which has its own ventilation and access points. Today, thousands of people and tons of goods pass through the Channel Tunnel every day, crossing beneath one of the world's busiest shipping routes without even noticing the extreme engineering under their train. Number 5, the Panama Canal expansion. The original Panama Canal, opened in 1914, already changed world trade by letting ships cut across Central America instead of sailing around South America. But as cargo ships grew larger, the canal started to become a bottleneck. The expansion added a new set of wider, deeper locks and new channels that can handle huge, new Panamax, container ships. Each new lock chamber is like a giant water elevator made of reinforced concrete, using sliding gates taller than a many-story building. Engineers had to design a system that moves millions of liters of water efficiently, while protecting the surrounding environment. Instead of wasting water, the new locks use water-saving basins that recycle a large portion of the water each time a ship passes. Construction meant working in heavy rain, unstable soils, and a highly active shipping route that couldn't simply be switched off. The result is a project that doesn't just move ships. It reshapes global trade routes by deciding which vessels can cross from one ocean to the other in a single day. Number 4, the Hong Kong-Zhuhai-Macau Bridge. This sea crossing stretches around 55 kilometers across the Pearl River Delta, combining long-span bridges, artificial islands, and an undersea tunnel into one continuous route. Designing a structure this long over the open sea brings several problems at once. Deep water and soft seabed conditions. Strong winds and typhoons. Busy shipping lanes that cannot be blocked. To solve the shipping issue, engineers built 2 artificial islands in the middle of the delta, then connected them with an immersed undersea tunnel section. This allows large ships to pass safely above while vehicles travel through the tunnel below. Foundations for the bridge sections had to withstand waves, currents, and saltwater corrosion for decades. Special steel, thick coatings, and regular maintenance routines are all part of the design. This project shows how modern infrastructure can mix bridges, tunnels, and even new pieces of land to overcome geography and connect entire regions. Number 3. The Large Hadron Collider, or LHC, at CERN on the border of Switzerland and France. From above, it looks like farmland and small buildings. Underground, there is a circular tunnel about 27 kilometers long housing the most powerful particle accelerator ever built. Inside this ring, beams of protons are accelerated to near the speed of light using thousands of superconducting magnets. To make those magnets work, they must be cooled to temperatures colder than outer space, using liquid helium. Maintaining that cryogenic system over such a huge loop is an extraordinary technical challenge. The tunnel has to hold an ultra-high vacuum, because even tiny bits of gas can disturb the particle beams. The alignment of components is so precise that tiny mechanical shifts can affect experiments. The LHC is extreme not because of its size alone, but because it pushes the limits of precision engineering, low-temperature physics, and international coordination, all to answer questions about the fundamental nature of matter, like the discovery of the Higgs boson. Number 2. The Three Gorges Dam on China's Yangtze River. It is one of the largest hydropower plants in the world by installed capacity and one of the biggest concrete structures ever built. The dam stretches more than 2 kilometers across the river and rises over 180 meters high. Building it meant diverting and controlling one of Asia's major rivers while continuously handling floods and sediment. Engineers had to pour enormous volumes of concrete in carefully controlled layers to manage heat buildup and cracking. The project also includes ship locks and a unique ship lift, a kind of giant elevator that can raise or lower vessels between different water levels. Three Gorges is powerful and controversial. It generates huge amounts of electricity and provides flood control, but it also led to large-scale resettlement and environmental changes. From a pure engineering standpoint, it represents one of humanity's most ambitious attempts to control a major river. Number 1. The International Space Station. Orbiting about 400 kilometers above Earth, traveling at roughly 28,000 kilometers per hour, the ISS is a modular laboratory the size of a football field built piece by piece in space. Each module was launched separately on rockets and then assembled in orbit by astronauts and robotic arms. Every connection, power, data, atmosphere, cooling, had to work perfectly in microgravity. Tiny errors could threaten the entire station. The ISS constantly faces extreme conditions. Temperatures that swing from very hot in sunlight to extremely cold in shadow. Micrometeoroids and space debris. The need for continuous power, which is provided by large solar arrays that must track the sun precisely. Life support systems recycle air and water so crews can live and work there for months at a time. On top of all that, the project depends on cooperation between multiple space agencies and countries, each contributing modules, vehicles, and experiments. The International Space Station shows what's possible when engineering is combined with long-term international collaboration. It's arguably the most complex single object humans have ever built.